All right, so today lesson 25A, function notation. This is actually a two-part lesson, and as you can see from the standards right there, part of this is ninth grade. In fact, the majority of this is ninth grade standard. We do talk a little bit about some of the 8th grade standards, but most of that stuff is the stuff that we have already talked about. So today our focus is on function notation. Function notation. So our essential question changes a little bit. How do you define, evaluate, and that is the big focus for today, evaluating functions at a specific value. As we get later on in this unit, we'll be comparing. We've already defined what a function was. So here's something we talked about a few lessons ago. We defined what a function rule was, and we looked at the relationship between input and output and domain and range, and how this function machine is really the same thing, or it represents the same idea as a set of ordered pairs in a table. And so the new thing for today is this function notation. When you use, and we read that as f of x to indicate outputs, and we need to add this to our notes. We have a blank area there. And this just tells us f parentheses x end of parentheses. We read that as f of x. Now sometimes when we are writing functions, we don't have to use the letter f. We can use g of x, and if you look at some of the other problems in your notes, you'll see g of x and h of x and things like that. So we have done lots of work with equations, linear equations like this. Y equals 2x plus 3. Well, f of x equals 2x plus 3 could also be graphed. So in a lot of ways, there are a lot of similarities between a linear equation and a function. And notice that the only difference here is that y is being replaced with f of x. And so what that means is that there are a ton of similarities between these two ideas. So I don't want you to think that everything is different, because really everything is pretty much the same. And so in the past, you may have been asked to evaluate that equation y equals 2x plus 3 when x equals 1. Well, when x equals 1, obviously we're going to take that value, substitute it in right there, simplify, and we will have the y value. So 2 times 1 is 2, 2 plus 3 is 5. So when we evaluate that equation, when x equals 1, y is equal to 5. Now several things are happening here. Remember, 1 is the input, and this is where we should start filling in some extra stuff in our notes. 5 is the output. And then also that leads us to this ordered pair right here, 1 comma 5. And I'd like you to also write the ordered pairs for each of these as we're going along. And this stuff right here, a lot of you had already filled this stuff in your notes because you already know how to deal with this stuff. So when x is 2, y is 7, because 2 times 2 is 4, and 4 plus 3 is 7. That leads to the ordered pair 2 comma 7. And I will let you, if you haven't already done so, go ahead and do the other two. And I'll get back to you in about 45 seconds. Find the y value, and then also write down the ordered pair. Okay, so when x is 3, y is clearly 9. 2 times 3 is 6, and 6 plus 3 is 9. That leads to the ordered pair 3 comma 9. When x is 4, 2 times 4 is 8, and 8 plus 3 is 11. That leads to the ordered pair 4 comma 11. Nothing even close to complicated with that. So now let's shift over to the function, which looks very similar to the equation. So if we are asked to find f of 1, one way of thinking about this is this. Function notation is really just a much more compact way of asking you to evaluate a function. And you have to admit, f of 1 equals is a lot shorter, a lot less writing than when x equals 1, y is equal to something. And that's really all that is happening here. So f of 1 means that x is 1. And then we're going to substitute 1 in to our function for x. And we have 2 times 1, which is 2, plus 3 is 5. Now, we had already done the math for that on the left. So, f of 1 is equal to 5. And just like the stuff on the left side, 1 is the input, 5 is the output, and that leads us to the ordered pair 1, 5. So f of 2 means x is being replaced by 2 in our function, right here. I know most of you understand that because we just did all the math off to the side, but x is being replaced by 2, and then you evaluate that function. So 2 times 2 is 4, and 4 plus 3 is 7. And that leads to the order pair 2, 7. So can you go ahead and finish off the last 3 in that block of problems? All right, so you didn't really have to do anything for f of 3 because we had already done the math off to the side there on the left. F of 3 is 9. That's leads to the order pair 3, 9. F of 4 is 11. Now, the new problem. F of negative 4. What is f of negative 4? It's negative 5. Very good. When x is negative 4, we have 2 times negative 4, which is negative 8, and negative 8 plus 3 is negative 5. And that leads to the ordered pair negative 4, negative 5. All right, so now let's change our function. And by the way, can you go ahead and down below this block of problems is this part right here. Fill that in. Remember, and this is just a reminder, because we're going to come back to replacing the word domain for input and range for output. So remember, the input also represents the domain. Sometimes we refer to it as the domain. And the output also represents range. Now, let's go to this function. So now I'm changing the function to g of x equals x squared plus 1. So we'll do the first one together here. G of 4 means we are replacing in our function x is being replaced by 4. So we substitute 4 in there. Make sure we follow the order of operations. And so that gives us 4 squared plus 1, which is 17 plus, or 16 plus 1, which is 17. The most common mistake is to forget to evaluate the entire thing. So g of 4 is equal to 17. And of course, that gives us the order pair 4, 17. So can you go ahead and quickly do 2, 3, and 4? G of 17 means we are evaluating the function x squared plus 1 when x is 17. So we have 17 squared plus 1, and that is 290. So that leads to the order pair 17, 290. G of negative 3 means that x is being replaced with negative 3. Negative 3 squared is 9. 9 plus 1 is 10. So G of negative 3 is equal to 10. And that leads to the ordered pair negative 3, 10. G of negative 7 will give us 50, and that leads to the ordered pair negative 7, 50. Could I get all of you to quickly do 5 through 8? So h of 5 means we're replacing x with 5 and evaluating, so that would be 13. So h of 5 is equal to 13. The ordered pair is 5, 13. Now, one thing I want to make very clear here, because this is going to help in the next block of problems, is that typically these ordered pairs are in the form x, y. And they still really are. But now, for function, y is being replaced with h of x. So in function notation, for this block of problems, they're really x, h of x. And once again, that's going to come into play in some of the problems we're going to do in a few minutes. So number 6, h of negative 2 is equal to negative 8, which gives us the order pair negative 2, negative 8. h of 0 is negative 2, which gives us the order pair 0, negative 2. Before we were rudely interrupted with the fire drill. Number 8, h of negative 7 is equal to negative 23. That leads to the ordered pair negative 7, comma, negative 23. Now, this next block of problems is kind of a lead-in to tomorrow. So this is really the same idea, except just in a different format here. So I'm telling you that f of x is equal to 4x for number 9. And I'm telling you that we have 3 different domain values. One of them is negative 1. One of them is 0. One of them is 2. So this is kind of like 3 problems in one. And so we're going to find f of negative 1. By the way, what is f of negative 1? It's negative 4. We're also going to find f of 0. What's f of 0? 0. And then we're also going to find f of 2. What's f of 2? 8. Now typically when we write the answers to these, we write them in numerical order from smallest to biggest. Now they may already end up that way in this problem, which they were, but if they're not, then you need to put them in order numerically. So go ahead and quickly do number 10 and number 11. Number 11. Number 10, the function is g of x equals 3x minus 9. So technically we're finding g of negative 1, g of 0, g of 2. And then when we write the answers in that format, we're typically supposed to write them in order from smallest to biggest. So if your answers weren't, it's because of the fact that you didn't hear me when I was talking about number 9. So those are not in the order of g of negative 1, g of 0, g of 2. I don't think they might be, but we need to write them in order from smallest to biggest. And then if h of x equals x squared minus 1, the 3 answers that we would get when the domain is negative 1, 0, and 2 would be in numerical order, negative 1, and then 0, and then 3. And your first problem should look like this. So basically what we're doing now is we're putting this whole function notation thing together. So the first problem here says to find f of negative 10. Well, you should be able to do that. Go ahead and do that. And let's do this in our notes packets. So what is f of negative 10?
17.
It is 17, because this is just like all the other problems that we were just working on. So since x is being replaced with negative 10, we take negative 10 and substitute it in there, and we get negative 2 times negative 10, which is 20, and 20 minus 3 is 17. So you can go ahead and type that answer in My Open Math. But now let's go to the second part. Here's what I want you to do. I want you to have a very quick conversation with your shoulder partner about what you think we might have to do in this scenario. And this scenario is, if f of x equals 1, what is x? Have a quick conversation with your shoulder partner. Any ideas on what to do? I heard some of you talk about it.
I think we would simply just replace f of x with 1 and replace it as 1.
Why can you do that?
Because they're equivalent to each other.
Yeah, right here. It says that f of x is equal to 1. So therefore they are equivalent to each other. F of x is equal to 1. So let's take f of x and replace it with 1. And once we do that, we now have this very simple two-step equation to solve. So by the way, when you have the equation 1 equals negative 2x minus 3, what is x?
Negative 2.
It's what?
Negative 2.
Right, you add 3 to both sides, divide both sides by negative 2. I'm not going to show all the steps there because that's a 7th grade problem. But it should be negative 2. So we said that this was 17 and this is negative 2. So you can go ahead and input those answers into My Open Math. And obviously they should be correct. And so now you have a problem to practice. Everybody do number 2 in that notes assignment. Okay, so that's how we deal with it when we are given an actual function. Now, what if we are given a graph? Well, graphs are very, very easy as long as you understand the relationship between a graph and specific values. So once again, like in the last one, if I were you, I would take very good notes in your packet on this one. So the first part of this problem says to evaluate f of negative 1. Well, the thing that we have to realize is that in this scenario, this means that we're evaluating when x is negative 1. So one way to look at this is saying when x is negative 1, what's the y or the f of x value? That's really what that is asking. When x is negative 1, what is the other value? What is the f of x value? What is the y value? So we just have to find the ordered pair that is on that graph. Well, the ordered pair that is on that graph when x is negative 1 is right there. Some of you said 0. No, that's when y is negative 1. That ordered pair right there is negative 1, comma, negative 3. When x is negative 1, y is negative 3. So f of negative 1 has to be negative 3. All right, so now we sort of reverse the process. So when the function has a value of 3, so this is like this in terms of an ordered pair. I didn't mean to do that. What is the x value when the y value or the function value is 3? Well, we look at the graph once again. So when y is 3, that is this ordered pair right here. Because that ordered pair is 2, 3. So when the y value or the f of x value is 3, the x value is 2. So once again, when the y value is 3, the x value is 2. And graphs are very, very easy as long as you understand the relationship to what is happening there. All right, so go ahead and submit that one, and then everybody try your number 4. So one of the things while you guys were shoulder partnering that is this. I heard a couple of you say, well, what I did was I found the equation and then I did it like I did number 1 and number 2. There's nothing wrong with that. You could do that. The only problem with it will come later on when we start doing the same thing with curves. And if you have a curve that you don't know how to find the equation for, well, now suddenly that method is not very viable. But for lines, that's perfectly acceptable. Okay? All right, so let's go now to number 5 in your notes. Now we have a table of values. Anybody have any idea what f of 6 would be? It's negative 94. Yeah, tables and ordered pairs are actually easier because, look, once again, we're saying that x is 6. So when x is 6, right there, f of x is equal to negative 94. And then when f of x equals 64, we're kind of reversing the process there. So when f of x, I meant to change pen colors. When f of x is equal to 64, what's x? 2. It is 2. All right, go ahead and submit that one, and then go ahead and quickly do number 6. And then we've got one more thing to deal with here. Go to the last idea for today, and that is basically the same thing as number 5 and 6, but now instead of a table we have ordered pairs. So if we are evaluating f of 2, that means x is 2, so you need to locate the ordered pair that has an x value of 2 and find the f of x value. So what is f of 2? It is 2 because we're dealing right here with this ordered pair right here. And so when f of x equals 16, what is x? And that is this ordered pair right here. So it is 14. Go ahead and submit that one. Quickly do number 8, and then you can get whatever you can get done in the homework assignment. And we are finished.